tear up here. Come here, Andres.
Oh my God.
Turn that off. No, turn that off. All right, so I have 2 weights here. These are each 1,000 grams, plus the weight of the pin attached to them. All right, so put your hands out. Put them like this, just flat like that.
If you
Okay. So
I swear to God.
So these both weigh the same thing, which means that their force on the ground, like downward, is the same, right? So since they both have the same weight, put your hands up. Since they both have the same weight, they should both have the same effect on him, right?
Yeah.
Okay. Put your hands up. All right, ready?
No.
Why?
Don't try that.
What are you afraid of? So this one doesn't bother you?
You better drop that one.
They have the same weight.
I don't care. That one's playing down.
All right, ready?
You're not.
All right, go away. Okay, so they are the same weight, but because the area of this pinhead is so much smaller, the force is all concentrated in that tiny little area, right? And I don't know what the area is if we do the width by the height of the pinhead, but it's tiny, right? It's like a millionth of a square inch or something. And so for that reason, there's a tremendous amount of pressure when you drop this, which is why it will punch through the skin. Whereas this has a pretty big area here, and so it's not going to punch through the skin. So that doesn't hurt very much, but if I do this, it's going to hurt. No, I'm not going to hurt. So that's what pressure is all about. It's about how the force is either spread out or concentrated in a small area. All right, let's write that down here. So pressure. You guys should have been here last period. The kid didn't move his hand. Okay, so pressure is just force per unit area.
God bless you. You're welcome.
So we can write that as an equation. It's really almost written out for us already. E equals F over A. And so looking at this, hopefully what I just said to you makes sense. If you have a smaller area, the pressure is going to be bigger, right? Anytime you have a fraction, if you make the denominator smaller, the value of that fraction gets bigger. So if you have a tiny, tiny area, like the cross-section of a pin, then the pressure is going to be really great. Or if the force is really big, then you're also going to have a lot of pressure. There's a few places where you see this, right? Knives, right? A knife has a long edge, but then it's very thin. So if you did length times width of the knife edge, you still have a really tiny area. You also see women's high heels have a lot of pressure because the heels are sometimes very small, like maybe 1/4 of an inch. So when you step with, say, 50 or 100 pounds of weight, and that tiny 1/4 of an inch, it tends to put dents in the floor, right? Sometimes even like break up concrete. So there's another place. Have you ever stepped on somebody's foot? What's up?
That's what they say, watch out for big girls.
Oh.
Wow.
The song.
Oh.
That song.
All right, let's do a problem here where we calculate pressure. This is really straightforward, so we'll just do one. So let's say a hammer plus a force of, and I'm going to use newtons because newtons is what I have on the worksheet. In America, we use pounds for force. In metric system, we use newtons. A force of 600 newtons to a, let's say, a board. You're just standing there banging on a piece of wood for no reason. And the area well, what's the area of a hammer? I have a hammer here. I use this for when students talk during my lecture. So what's the area of the front of here, right? So it's like, I don't know, inch by an inch maybe?
About a quarter.
Think so?
In between a quarter.
A quarter? Oh, okay. It's wider. I gotcha. Okay. And then, yeah. So if I was doing meters, right, it'd be like .02 or something, like some really small amount.
Can't
So
you do
let's
like
use that.
3 centimeters?
Huh?
3 centimeters.
Well, it's like 2 centimeters across, right?
Yeah.
Like 2 by 2, so it'd be like, okay, 4 squared, you're right, yeah. So I get what you're saying. So if it was in meters, it'd be .02 times .02. We're imagining it's just a square, so we're thinking of it by our square crap. So anyway, let's just say the area is .0004 meters squared. Let's go with that. Right. So some tiny amount in meters. And the question is, what pressure does it apply? So this is really simple. We're just going to list our givens. Force is 600 newtons. And area is 0.0004 meters squared. So the force, the pressure is going to be force over area, 600 newtons over 0.0004 meters squared. Let's have them out there.
Oh, so you're dividing?
Yeah, 600 by that number.
Okay.
About 1.5 million. I might be off by a
Yeah.
zero. Yeah,
Yeah, that's right.
newtons per meter squared. And if we want to do the same thing with, let's say, can I erase here? You good? Okay. Let's do one with American units. In fact, you stay with the same hammer, and let's just try to use the units that we're used to. Let's say the force is in pounds. It would be, I don't know, about 120 pounds. Let's say that's the force that I swing the hammer with, hits the object with. And let's say the area of the head of the thing is, I don't know. Let's say in inches squared. How many inches across is that? A half an inch? So 0. So a half times a half is a quarter. So a quarter inch squared, right? Square inch. So if we were to do this with the American units, we get 120 pounds over 0.25 inches squared, or square inches, whatever you prefer. So this is going to be 480 pounds per square inch, also known as PSI, right? But I don't want you to use PSI in here because you can't cancel the inches on the bottom if you write PSI. So these are, I estimated the numbers, but those are kind of close. So you see, depending on which units you use, you can get really big numbers or really small numbers. If we took our hammer here, where's my hammer? There it is. Let's say this, quarter inch squared, right? Let's say we started filing this down until the hammer got real pointy, really small in the front, right? And instead we made the area 0.001 inches squared. What does that do to our pressure?
It increases.
Right, it's going to be really big. It's going to be 120 divided by that, which would be like 120,000. So making it really pointy makes the pressure really big. If I made the area really, really big, if I put I taped a piece of wood on here and it started hitting things, then the pressure would be really small. Right, so bigger area means smaller pressure, smaller area means bigger pressure. All right. Let's do one problem where you got to find something other than pressure. And then I think we'll be done. So let's do if a woman's heel has, are you wearing high heels? It would have been really convenient if you were, but who wears them like one day, right? A woman's heel has an area of, area has an A in it, 0.2 inches squared, right? So those things are pretty small, some of them heels, right? And she applies a force No, wait, we're going to solve for force, aren't we? So she applies a pressure Sorry, you can erase. Just scribble. Of, I don't know, pick a number.
21.
Yeah.
505.
I was looking for something in the thousands. Let's go with 21,000. 21,000 pounds. Pounds is LBS per square inch. Right? We're going to find out in a second if she is. All right. What is the force? So this would be the force that one heel applies on the ground, which is almost half the weight. You figure a little bit of weight's on the front of the feet, most of it's on the heel, but it's evenly divided between two. Although when you lift one leg, then it's all on one shoe, right? So,
Yeah.
all right. So what are we going to do here? We're going to write our equation. Pressure equals force over area. We're going to list our givens. Area is 0.2 inches squared. Pressure is 21,000 pounds per square inch. And then force is what we're looking for. That's our question. Okay, so we need to solve for force, right? What are we going to do?
Yes,
100 pounds over 1 inch squared equals F.
No, absolutely not. You're right, but no, we're not going to do that. She did that to make me unhappy. No, we're going to solve algebraically before we plug in numbers, right?
Gotta multiply.
Multiply up F, A.
And then you divide it.
Oh, whoa, calm down.
Right?
No, you got to multiply both sides by A, because we're going to get F by itself.
I said that.
You said that.
Yeah.
No, we didn't.
Yeah, you did.
Are you serious?
Yeah.
All right, whatever.
I'll speak.
All right, so multiply both sides by A. So now we got A times P equals force. So now we can plug in numbers. So it's going to be 0.2 inches squared times 21,000 pounds per square inch. 0.2 times 21,000. 0.2 is a fifth, right? So what's a fifth of 21,000? It's like,
4,200.
thank you. 4,200 inches squared cancels. Our answer comes out in pounds, which is good news because we were looking for force.
So all you did was find it was 14 times 21.
Yes,
Something like that.
that is what you did. All right. Other questions? Can we do any more problems, or are we good with this?
We're good.
Okay. Yeah. Tomorrow we'll talk about, not tomorrow, I'll be out. We'll talk about gas pressure.
Are you gonna be out?
Can you turn that off someone?
All of
Why
it?
are all these little? It was not.
What, the recording?
Yeah.
Not you did it.
Yeah. You wanna do it?
Wait,
Yeah, you got
why are you gonna be out? What do you want me to do?
my team?
Yes, I can.
Mister.
I can and I will.
Why is we out?
So this time it's for something else.